Good morning, everyone, once again. Thank you, Ewe. First and foremost, I would like to thank the organizers of this wonderful program. You guys have done a very good job of bringing all of us here together today. I also like to thank them for this opportunity given to me to speak to us. A little bit about myself. I have a background in networking and systems engineering. I started my career in IT a couple of years back, and I am someone you can call your typical IT guy. I've done networking, I've done servers, I've done IT support. So currently I am transitioning into DevOps and site reliability engineering. So why am I here today? I'm here because a couple of years back, the company I work for, Carbon, we started on a journey to transition into DevOps. And I'm here to share with us our journey, some of the things we wanted to do then, how DevOps helped us to achieve what we wanted to achieve, the challenges we faced along the process, and some of the lessons we learned. I don't know, does anybody here knows one credit? Have you heard of one credit? Okay, I'll be shocked if I actually see more than a couple of hands. So, as at 2012, we were one credit. We were basically into learning, strictly learning. And our target market was quite small then. We learned before you can get a loan from us, you must be a salary earner, and you must be working and living in Lagos. If you've taken a loan from us before, you would realize that the process is quite manual. It's very labor intensive. We had a series of forms to fill, and you also have to provide a lot of documentation before you can be considered for a loan. And then, as at then, we're also averaging about 40 applications per day, which is quite small. In terms of tech, we didn't really have much. We had an on-premise data center, or what I can call a server room. We had a bunch of physical servers. Applications were mostly running tools that support our internal processes. Talk about things like Microsoft Exchange, Active Directory, and a payroll software here, an accounting software there. We were pretty much traditional in every IT sense. And this couldn't support the ambitions we were trying the ambitions we had then. So fast forward to 2016. We wanted to reach significantly more people, wanted to break the boundary that we were limited to as at then. Want to be able to reach customers across the 36 states of Nigeria. Also, we wanted to make the application process simpler for our customers, and we don't want them to have to fill several forms before they could apply for a loan from us. And then we also wanted to make our service available 24/7. So basically, we want you to be able to wake up, say, by 3 a.m., apply for a loan, and get disbursed almost immediately. So our ambitions were quite high, and it became obvious that the kind of infrastructure we had as at then will not be able to support what we're trying to do. So migration to the cloud became the obvious next step. We had to migrate to the cloud, but we didn't do it immediately. For some of us that are familiar with Pay Later, I don't know, well, who has applied for Pay Later when around the time we started, say 2015, 2016? Okay, you will remember actually that we had a web-only platform, exactly. So, we were running on a VPS server somewhere, and it was doing fine for a while, things were going smoothly. But then, having a web-only portal did not allow us to scale as we wanted. It was 2016, mobile phones were everywhere. So we had to release our app on a mobile platform. So when Paylater was released on the mobile platform, of course, the reception was quite massive. We started having lots of requests. And the BPS we were running on then couldn't support our operations anymore, so we had to go full scale cloud. In migrating to the cloud, some of the things we considered were the scalability of the platform. We had to be able to scale at a push of a button. It became very, very critical for us. The system we are using had to support automation to a very high level. And then security was also critical for us. When we're reviewing AWS, we saw things like security groups, network access control list. I'm a network person, so of course all these tools, I fell in love with them instantly. And we also have things like identity and access management. All these tools gave us the ability to be very granular with our security. Also very important when we were considering the move was the need for us to be able to observe our systems to see how well they are working. We need to be able to get metrics from everywhere. Thankfully, the cloud provided us a platform where we can collect our data, transform them if need be, and centrally store them in a place where we can analyze them and hopefully get some actionable insights from. So AWS became the obvious winner, aside from the fact that it was the most popular platform, as at then it still is anyways. A good number of our team members were already heavily invested in learning how to do AWS. And then our architecture had to be designed to be distributed. We do not want a single point of failure. Personally, I value my sleep a lot. I do not want to receive a message that one server is down at 2 a.m. No, I don't want to do that. So we had to eliminate single point of failure by making sure we have multiple servers serving our request. So we settled on AWS. Okay. Now, all these features, all these tools, they are great, they are wonderful. But a tool is only as good as the person using it. A tool is only as great as the kind of problems you're able to solve with it. So, one of the things we considered, it became obvious that improving collaboration, improving communication among our team members will be a very critical factor in determining whether we'll be successful in our adoption of DevOps. So, yeah, just like every other traditional IT company, we have several teams handling software, another team handling network, another team handling your servers and whatnot. So we had to find a way of ensuring that all these teams collaborate effectively. So which led us to this. First and foremost, we had to de-emphasize the use of emails. Don't get me wrong, emails are great. They do what they need to do quite well. We still use it. And but you quite agree with me that in an agile environment, emails they're just too slow, really. They are very limiting in what you can do if you want to be agile. So we had to de-emphasize email. And then we had to develop an environment that fosters collaboration. This we did by making sure all members of our engineering team, that's infrastructure and software guys, we collaborate on a daily basis. We have joint stand-up sessions every time. We make sure that every member of the team is aware of the project's lifecycle and what they have to do to make sure the project come to life. And then, more importantly, we had to make sure we have a very effective feedback system. If you're working on a project and you hit a snag, you need to be able to send feedback back into the system to let us know what you're doing wrong or what is not working as it should, and how we can help you solve the problem. And then containerization became a no-brainer, really. I mean, a good number of us are developers, and I'm sure we know about containers. Using containers help us to have an homogeneous environment across our development, staging, and production environment. Speak of the kind of scalability you can get by leveraging containers, and how quickly you can automate things when your application runs on containers. I mean, the benefits from containerization is quite, has been quite wonderful for us. And what's DevOps without tools? I know we've heard so many DevOps philosophy that it's not about the tool, it's the people, it's the process, it's this and that, but tools are also, we need to use tools actually. We need tools to work. While the emphasis is not on the tools, you need tools to get the job done. So we had to learn quite a number of new tools. Personally, I had to go back and brush up my programming skills a bit. And yeah, in our team, we started adopting DevOps in small projects. Traditionally, we know that the development team has been more agile, sort of because they sort of collaborate on a daily basis. So in the infrastructure team, we had to do a lot of catching up. And one of the ways we did this was by implementing a small project. Now, the focus of this was not in the project per se, but in the process. Implementing this took us through. In the life of the network engineer, your typical day, you may have to back up your router configuration. Am I right? Okay, so a typical network admin will log in into the router, initiate the backup, and then once the backup is complete, you probably copy it out and store it in a secure location somewhere. So, I mean, if you enjoy doing routine, mundane stuff like this, yeah, maybe you can keep on doing it every morning, but we figured this is a very good candidate for automation. And then, so, we set out to automate this very simple process using a bash script. The script logs into a router, it initiates the backup for us, and during the process, it removes any form of secrets or passwords that might be in the configuration file. And then the script is pushed into a code repository where other members of the network team can see or can collaborate, pass comment, and hopefully make changes if need be. Now, going through this process, we were able to figure out that, okay, if you can do this, then you can also automate the process of rolling out a new configuration change to our routers, for example, with the push of a button without having to manually log in into the router. Yeah, this was life-changing for me personally, because I saw a whole lot of possibilities in our journey into DevOps. Yeah, these are some of the tools we used and we are still using. AWS, Amazon, EC2. If you use Amazon very well, you will know that directly or indirectly you use EC2. The bulk of their services under the hood runs on EC2. Am I right? Okay. So AWS Code Builds allows us to build our applications mostly using Docker containers and then using binary executables. For code commit is more like Bitbucket or Git, but on the AWS platform. AWS Code Deploy, yeah. So with AWS Code Deploy, we are able to roll out deployments to our ECS cluster or an EC2 instance. Of course, the process will be automated. Once your code is pushed into your repo, Code Deploy takes it and then deploys it to your server. Code pipeline enables you to create a pipeline, an end-to-end pipeline, depending on what you want. If you want to build an image, You have it. You want to automate an entire deployment lifecycle, you have it over there. Yeah, we have Slack here. I want to believe a good number of us here use Slack. Slack is a communication tool that we like a lot at Carbon. It allows us to collaborate a lot. Developers love it. I love it. A good number of our systems are deeply integrated into Slack. I mean, we get alerts at the tip of our finger. We don't miss out any alert at all. So Slack has really helped us in our journey. And it's funny because this collaboration thing started from the top. We did not have to get management buy-in, so to say. We're actually the ones pushing for it. So it became very easier for us to make the transition. And in choosing your tool, you have to bear in mind that the tool you are using to solve your problem must be cost effective. What do I mean? For example, the personal note, the very first CI/CD pipeline I did was done using Bash. So what does it do? So I wrote a script that periodically checks my code repository for changes and immediately detects any changes. It pulls down the code and then redeploys my service. You might argue that it's not really a CI/CD pipeline because I wasn't using all the maybe the 7 CIs and the Travis CI and the likes, but it gets the job done for me and I'm quite happy. In fact, that service is still in production today. So the tool must fit the cost and the solution you're trying to achieve. Yes, so what's DevOps without a pipeline? Almost everything is a pipeline today. Data pipeline, CI/CD. This is a sample architecture of one of our deployment pipeline. As you can see here, we have the red line and the blue line. The red line indicates a build pipeline. So basically, a developer pushes your code to the repo, and a webhook triggers the build process. And once the build is done, the image gets pushed into a Docker repository, which is an elastic container registry. Another pipeline takes your code and takes it all the way to an ECS cluster. ECS is Elastic Container Service, a container orchestration platform by AWS. Our code gets deployed and gets exposed to the public using a load balancer. That is, if the service is meant to be public facing. Okay, for some of the lessons we learned in the process, we realized that automation is good, automation is great. We encourage people to automate as much as possible, but you simply can't automate everything. Automation is a tool, is a double-edged sword, and if you're not very careful with it, you can automate yourself out of business, and we don't want to do that, really. And yes, we learn to experiment. There are a whole lot of tools out there, quite a lot. If your focus is on tools, you will not end up, you can't learn all of them. That's just the plain truth. So learn to experiment, know what works and what doesn't work for you, so that you can make an informed decision. And then databases. We decided to leave databases out of infrastructure as code, primarily because databases are meant to be stable. There's a whole lot of hassle that has to go into trying to automate some of your configuration changes when you are dealing with databases. So we decided that it's best we leave databases out of IAC. Now, you cannot have a tool that magically solves all your problems 100%. No. You have to learn how to make intelligent trade-offs. You have to analyze your problems and know what works and what doesn't work, so that you can effectively say that, okay, I think I'm getting the best value from this process. And then we learned that microservices should be microservices. Shouldn't be a bunch of monoliths that are talking to each other, which is some of the mistakes we made when trying to architect using microservices. When you're doing microservices, you decouple your applications to the point that they have to just talk to each other using messaging systems. Okay, this is Carbon today. We currently have about over a million downloads from Google Play Store. We still do loans, but we are no longer focused on loan. We offer other services too, like bill payments, wallets, investments, and funds transfer. Now, the cloud, the agile nature of the cloud has helped us to be able to achieve all of this, and DevOps as well. If we did not just wake up one day and said, okay, we want to do DevOps. No, DevOps was more like a natural next step for us based on our goals, based on the things we wanted to achieve. So it became very important for us to adopt another mindset, another ideology, to change a whole lot of our process to enable us to reach where we are today. And yeah, Carbon is everywhere today, literally. Thank you. So, I'll take questions if any.
Any questions? I like that line, to make yourself out of business. So let me give you personal experience on that line. It's a very scary tool in AWS called autoscaling. Very scary. I almost automated myself out of my company's business actually. When I put my autoscaling group to like 1500. For some reason, it's all over the place. So yeah, that's an example of autoscaling yourself out of business. So I mean, part of what is understanding what you are doing is very, very important. Any questions for David? Yeah. Okay, sorry.
My name is Marcos. A full stack JavaScript developer and DevOps engineer. I work at Angela. What is Angela? Yeah. So, in your presentation, I saw that you're using Jenkins code deploy, code pipeline for your CI/CD. So, and I know that especially Jenkins, yeah, I know it I can't do CI/CD, I mean full scale. So is there a reason why you are combining the three?
Okay. Okay. So I'm going to say we started by using Jenkins actually. We used Jenkins extensively, and but then we had to do a project where we had to leverage AWS tools primarily. And so we had started considering what AWS had to offer in terms of developer tools. I mean, for me, it was like, I never knew that this goodies was there before for me to use that. I mean, a tool that was deeply integrated into AWS from end to end. So that was the primary reason why we went with, we started using AWS developer tools because of the deep integration it already has with AWS infrastructure. I mean, with code deploy, you can deploy using rolling updates or using blue-green deployments by just the push of a button, really. So with Jenkins, we have to start doing a lot of customizations like installing plugins and yeah, it's just a lot of hassle, really. And we still use Jenkins, but hopefully we would migrate fully to using AWS developer tools. I hope I've answered the question. Okay.
Okay. My name is Kenneth.
Alright.
Okay, my question is, what is your disaster recovery plan like? Assuming your system goes down, do you have a step guide that's followed to recover your system, or just?
Okay. We run on AWS, and an AWS person, you will know that AWS advises you, they recommend that you do multi-AZ deployments all the time. So as much as possible, we try not to get to the point where our service is completely down. That is why we leverage all the high availability tools available on AWS. Things like autoscaling now, for example. Things like having multiple replicas of your containers running. Yeah, so that's basically it, really. Okay.
What I was looking at is like, have you guys thought of in a situation where your system goes down, or maybe an availability zone, or all of them goes down? Have you ever thought of that?
Whatever we borrow, we
Well, that's a very interesting question. An entire availability zone going down. Yeah, it can happen really, but I don't even want to begin to imagine that kind of thing. Yeah, but then, we are not using one region. We use multiple regions when provide our services basically. So we never had that kind of situation. So we are hoping when that situation comes, our other region will be able to kick off and take control of our services. Yeah. So.
Okay, my name is Larry.
All right.
I work as a software engineer in Tech Advance. So, what's the cost implication? I mean, what does it look like when you introduce DevOps in your workflow, as against the traditional way of pushing and then managing your servers? And then secondly, I would like you to also try and compare it with Carbon when you guys are doing the normal traditional way and when you moved to practicing DevOps.
Okay, in terms of costs, if you study cloud computing, then from the business point of view, you will realize that the initial investment is actually very small when you're moving to the cloud, as compared to if you want to do something similar on premise. Like now, I need a 32 gigs of RAM server to host my analytics platform. If I'm buying that, I want to run that on premise, it will take me weeks to get that server up and running. But doing the same on cloud is just a case of a button, 2-3 minutes, I'm done. So the initial, and once, if the whole workload is supposed to run for, say, a week or 2 weeks, I'm done, I terminate, I'm good, life continues. Now, regarding to cost over time, yes, the costs tend to build up, but you have to now do a cost versus benefit analysis. This thing I'm getting, if I'm going to come down to on-premise and try to replicate it, will I get the same value? I don't know if you understand what I'm trying to say. So, it all boils down to the costs and the benefits you're getting. We are deriving a lot of benefit from leveraging the crowd, really. So, in terms of cost, I would say it's been a money well spent for us. So,
I wanted to add to what you said. Okay, so there's something we call CapEx and OpEx. Now, the problem is businesses don't measure OpEx, they only measure CapEx. So what I mean is, what does it cost to set up the server in terms of the server cost? For the time, the learning, the effort, nobody measures that. Do you understand? So those are some of the things that can actually hinder a business. It's going to take you 1 week to actually learn how to set up something. You understand? You might not be able to factor that cost. So some of the costs that come in that DevOps can take off for you in terms of automation and all the things he's talking about. Just wanted to add to what he said.
Hi, my name is Steven, and I'm engineer DevOps. I work at Market. So I just want to ask, you're transitioning into cloud generally. I mean, I want to know the challenges you guys faced based on the fact that basically everybody, basically the whole company was being run manually, and then we're trying to transition into cloud. So I want to know the challenges you guys faced and how they overcame?
Okay, in terms of the challenges we faced, just like when you're learning something new, there's always that initial challenge of, okay, how do I get up to speed with this new thing I'm learning? When the business is on your neck, pushing you to deliver quickly. So we had that challenge of time and time constraints to learn as much as possible in a very short period of time and get the business up and running. Also, it's the mindset change thing was also very challenging because mindset is not really something you learn as it's an experiential thing. You have to have gone through a process to be able to fully internalize what the mindset change as regards DevOps means. So those are basically our major challenge really. So hope that answers your question. Okay. Alright. Hi.
Hi. Anybody have any other question? We can't take all. How many? 1, 2, 3. How many people, please? Can you raise your hands? Let me just. Okay, 2. Okay, please. I will. So just those 3 people, please, so that we can move to the next speaker quickly. All right. Thank you.
Yeah, my name is Ugo. I'm a DevOps engineer for Wema Bank. I'd like to know how did you enforce people like from moving from regular way of doing things to moving to DevOps? How were you able to ensure that everybody compliance is what I'm basically
Okay.
that has been really something I want to get clear.
Okay, I think I said something similar when I was giving the talk. There was no enforcing. So it was a process. We didn't even know DevOps wasn't even a thing then. It was just a process whereby we knew what we wanted to do, and the tools that came our way, the processes that came our way was more of a natural next step. You saw the example I highlighted about people in the infrastructure team having to automate a simple project. Yeah, so that was basically how we get people to transition, by leveraging small projects to help us internalize all the tenets of DevOps, really. So there was no forcing, it was a slow and steady progress. Yeah. Last question, I suppose.
My name is Lawal DevOps engineer at Amazon.
Okay.
So this isn't really much of a question, it's more addressing the question he asked earlier about cost.
Okay.
Now, so from my little knowledge, I realized that it's so easy to implement DevOps, especially in small scale businesses. You find that there are so many, in fact, most tools are open source, right? So, and they have this thing where for small scale or small number of projects, you'd have like majorly free utilization. That you would only have the problem when you're ranging into hundreds of projects and all that. Because, okay, for example, TeamCity, right? So for TeamCity, you would find that you have 300 projects, like you have 100 build configurations free, right? With 3 build agents. And I mean, if you're running a small scale business, you'd rather, and for DigitalOcean has, I think for, you can start up servers, like if you have like a small server, depending on the resource you need, you can start, like you can raise like small servers and all. So transitioning into DevOps compared to cost, right? I think it's not that much of a reach as people would see it. I don't think I'm answering the question. Like it's not that much of a reach. And for a large business, I think for a large business, you'd have to weigh more of the opportunities, and it's more of the availability, stability over management, money management. You get the trade-off. It's an opportunity cost, but the benefits that you would get from DevOps would outweigh any cost implications.
Okay, good afternoon. My name is Folisho, infrastructure guy at Swift Networks. My question is from the security side to your presentation. So I was just curious, like how do you manage or handle customer or user data and the likes? Like from the fact that you're operating in a Nigerian environment, if I'm correct. Okay, so like how do you, like we have regulatory bodies, what are those things that you are storing on the cloud? How do you secure those things? Maybe data, or are you taking card info and stuff? I just want to understand, like from the cloud angle, how you handle all those things.
Okay, can you hear me? Yes. Okay, from security standpoint, we all know that AWS has a wide array of security tools. For example, if you're storing stores in S3, for example, you can encrypt your data in transit, also encrypt it at rest. If you've been following our progress, then you know that we're just PCI DSS certified. So in terms of compliance and the security, I think we're there. AWS has a very fantastic platform, and we deeply utilize them to make sure our customer data is safe and secure. We do a lot of encryption, and of course, if you know IAM role in AWS, you will know that it allows you to be very granular with your security. Not just anybody will have access to your console, your database, for example. And yeah, we are quite secure. We do the very best of our ability to make sure customer data is very safe and secure in our environment.
All right. That will be the last question. Please, a round of applause for this.